This is SpaceTime Series 27, Episode 1, for broadcast on the 1st of January 2024. Coming up on SpaceTime, black hole radio signals helping to unveil the secrets of massive galaxies, a close encounter with the most volcanic world in the solar system, and China launches its top secret reusable spaceplane. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that supermassive black holes at the hearts of some of the largest nearby galaxies are also among the brightest radio wave sources in the universe. The findings, reported in the publications of the Astronomical Society of Australia, are based on new observations using ASCAP, the Australian Square Kilometre Array Pathfinder radio telescope, an array of 36 12-metre parabolic dishes spread across outback Western Australia's Murchison region. The research was part of RACS, the Rapid ASCAP Continuum Survey. The study's authors wanted to find out whether radio waves are constantly being emitted from the most massive black holes, monsters millions to billions of times more massive than the Sun. Because the formation of new stars and galaxies can also produce radio waves, the research team focused instead on galaxies with minimal or no star formation. The study's lead author, Associate Professor Michael Brown from Monash University, says the team measured radio waves from the largest galaxies in the nearby universe, delving into the mysteries of radio waves emitted by the most massive black holes. Brown says ASCAP was ideal for the job. Not only is it capable of surveying vast areas of the sky, but it was also more sensitive than previous comparable radio surveys. Of the 587 nearby galaxies scrutinized by the survey, all 40 of the largest galaxies examined were found to be emitting radio waves. Brown says while it's possible there is some low-level star formation hidden in these galaxies, black holes do seem to be the most likely cause for what's being detected. Interestingly, the study also revealed variations among radio wave emissions among the very biggest galaxies, with some proving to be significantly more powerful than others. For instance, Galaxy ESO 137-G6 exhibited radio brightness approximately 10,000 times greater than that of Galaxy NGC 6876. The authors were also able to uncover differences in how galaxies were shining in radio waves. Now, this could be providing new information about their central supermassive black holes and how they power the surrounding galaxies. Brown says exactly why some galaxies emit more radio waves than others is still a bit of a puzzle. However, the observations show that galaxies that are powerful sources of radio waves appear to rotate slower than comparable galaxies that are weaker sources of radio waves.
The reason I'm looking at the radio is these galaxies, these really big galaxies, they all have really, really massive black holes in them. And when you feed these black holes, they can produce radio waves. And a classic example of that is Messier 87. But it hasn't been clear if all the black holes in these galaxies have been fed before. So I wanted to have a close look at these galaxies and see, can I see any radio emission at all from these galaxies? Are they all emitting radio waves, which would suggest the black holes are being fed, or are some of them switched on and are some of them switched off?
What have you found?
Every single one of the 40 really massive galaxies we've looked at has detectable radio emission in this new survey from the Australian Square Kilometre Array Pathfinder, which is much more sensitive than the previous generation of surveys. And so we're finding all of these galaxies have radio emission, although how much radio they emit varies a lot. The brightest galaxies are a factor of 10,000 brighter in the radio than the faintest galaxies. So there's still a lot to learn.
And it wasn't just the brightest galaxies compared to the faintest. Their rotational rate was also involved.
Yeah. So one of the big puzzles is why two galaxies that look superficially otherwise the same vary in radio power by a factor of 10,000. And one of the things that we found comparing with measurements of the galaxy's stars move around the galaxy is that the galaxies that have net rotation, or quite a fair bit of net rotation, have lower radio powers than the ones that don't show net rotation. So it looks like there's some connection between the radio power and perhaps how the black hole's being fed and how the stars are moving around within these very massive galaxies.
And the galaxies you looked at, were they a mixture of ellipticals and spirals?
So for this study, we focused on the elliptical galaxies. One of the reasons that we looked at the elliptical galaxies is that they generally don't have star formation, and star formation can also produce radio waves. So to sort of help clarify that we're seeing radio emission from a black hole rather than radio emission resulting from star formation, we focused on elliptical galaxies, M87 being a classic example that might be familiar to amateur astronomers.
It wasn't just a few. You looked at something like 587 of them. That's quite a task, and you mentioned ASCAP earlier. That was able to help.
Yeah, so we basically looked at every elliptical galaxy that was brighter than a particular infrared magnitude just to have a sort of very clean, well-defined sample. And we were most interested in the massive ones, but we're interested in all the elliptical galaxies in the nearby universe. And this new survey, the Rapid ASCAP Continuum Survey, has just been marvellous for looking at these nearby galaxies. It's covered 83% of the sky. Depending on how you measure it, it's 3 times more sensitive than the previous comparable survey. And it's only a preliminary survey with ASCAP. So, one of the things that's great is we're already getting this great science from a preliminary survey. In the coming years, there's going to be the extragalactic map of the universe, and that's going to be probably an order of magnitude better again. And so there's all this marvellous science being enabled by this Pathfinder telescope.
What's happening next?
So one of the things that I'm really interested in following up is this connection between how the galaxies rotate and the radio power that's coming out of these galaxies. It's giving us a hint about how black holes are being fed. And so there's a couple of Australian surveys looking at how galaxies rotate. There's a survey called SAMI, which was on the AAT, and its follow-up called Hector. And they're going to be great for understanding that. And one of the things that's interesting is that there are a few exceptions to this fast rotation, low radio power, slow rotation, high radio power sort of correlation. So, for example, NGC 5128, Centaurus A is an exception. It's got quite a bit of rotation, but it's also an odd elliptical galaxy because it's also got star formation and stuff like that going on in it as well. So there's some clues that perhaps, exceptions happen when you merge galaxies together and get a burst of star formation. So sort of exploring these correlations and also these exceptions, I think, is going to be interesting in the coming years. One of the things that's fun about this study is it's using some of the preliminary ASCAP data, and it's just going to go so much further in the future. So, we're just sort of kicking the tires right now and getting some really exciting results. So I'm just really looking forward to seeing where the full wealth of data from ASCAP takes us. That's going to be really fun.
When astronomers talk about the nearby universe, what do you mean?
Yeah, look, it's a bit of a moving target. In this case, we're looking at sort of in the ballpark of within 100 megaparsecs or 300 million light years, give or take. So a lot of these galaxies that I'm looking at are in the Messier catalogue and in the NGC catalogue, both of which are sort of familiar to amateur astronomers. So there's quite a few galaxies in my sample that people could see with, say, a 20-centimetre Dobsonian telescope.
That's Associate Professor Michael Brown from Monash University. And this is SpaceTime. Still to come, a close encounter with the most volcanic world in the solar system, and China launches its top-secret reusable spy plane. All that and more still to come on SpaceTime. NASA's Juno spacecraft has just completed its closest ever encounter with the volcanic world of Io. Swooping down to within 1,500 kilometres of the Jovian moon's surface, the close encounter has generated a massive amount of data. Juno's principal investigator, Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says by combining data from this flyby with previous observations, the Juno science team is studying how Io's volcanoes vary. Bolton and colleagues are looking at how often they erupt, how bright and hot they are, how the shape of the lava flow changes, and how Io's activity is connected to the flow of charged particles in Jupiter's magnetosphere. A second ultra-close flyby of Io is slated for February the 3rd, when Juno will again come within 1,500 kilometres of the surface. The spacecraft's been monitoring Io's volcanic activity from distances ranging from 11,000 to 100,000 kilometres, and has also provided the first views of the moon's north and south poles. Juno's also provided close-up flybys of Jupiter's icy moons Ganymede and Europa, both of which are thought to contain massive subsurface oceans, Europa's being global. These latest flybys are allowing scientists to investigate the source of Io's spectacular volcanic activity. They want to know whether a magma ocean exists underneath its crust, and also the importance of the tidal forces from Jupiter, which are relentlessly squeezing and pulling on the tortured moon, generating the friction which is heating the moon's internal structure, melting it, and producing the magma. Now, in the third year of its extended mission to investigate the origins of Jupiter, the solar-powered spacecraft will also explore the Jovian ring system, where some of the gas giant's inner moons reside. But certainly for now, Io, the most volcanic world in the solar system, remains the primary focus. And all three cameras aboard Juno have been active during the Io flybys. The Jovian Infrared Auroral Mapper takes images in infrared, and it's been collecting heat signatures emitted by the volcanoes and calderas which cover the moon's surface. The mission's Stellar Reference Unit, a navigational star camera, has also been providing valuable science, obtaining the highest resolution images of the Ionian surface to date. And the JunoCam imager has been taking spectacular visible light colour images. In fact, JunoCam's given us some of our best views of the entire Jovian system. Remember, it was originally only included on the spacecraft as a public engagement tool, and it was only designed to operate for the first 8 flybys of Jupiter. With 57 close encounters now under its belt, Juno and its cameras have endured one of the solar system's most punishing radiation environments. Still, the culmination of the effects of all this radiation has begun to show on JunoCam. Over the last few orbits, images from flybys show a reduction in the image's dynamic range, and it's also starting to show the appearance of stripy noise. Engineering teams at NASA's Jet Propulsion Laboratory in Pasadena, California, have been working on solutions to try and alleviate the radiation damage in order to keep the imager going. After several months of study and assessment, the Juno team have adjusted the spacecraft's planned future trajectory to add 7 new distant Io flybys for a total of 18, extending the mission plan. After the next close flyby of Io on February the 3rd, the spacecraft will fly past the fiery moon every other orbit, with each orbit growing progressively more distant. The first will be at an altitude of 16,500 kilometres above Io, and the last at around 115,000 kilometres. The gravitational pull of Io on Juno during the last flyby on December the 30th reduced the spacecraft's orbit around Jupiter from 38 Earth days to 35. And after the February 3rd flyby, Juno's orbit will drop to just 33 Earth days. After that, Juno's new trajectory will result in Jupiter blocking the Sun from the spacecraft for about 5 minutes at a time when the orbit is at its closest to the planet, a period known as perigove. Although this will be the first time the solar-powered spacecraft encountered darkness since its flyby of Earth back in October 2013, the duration will be far too short to affect its overall operations. With the exception of the February 3rd perigove, the spacecraft will encounter solar eclipses like this during every close flyby of Jupiter from now on, through the remainder of its extended mission, which ends in late 2025. Starting in April, the spacecraft will carry out a series of occultation experiments that'll use Juno's gravity science experiment to probe the composition of Jupiter's upper atmosphere. This will provide more key information on the planet's overall shape and internal structure. We'll keep you informed. This is SpaceTime. Still to come, China launches its top-secret reusable spaceplane. And later in the science report, the World Health Organization has declared NJ1 a new COVID variant of interest. All that and more still to come on SpaceTime. China claims it's carried out another successful test flight of its top-secret Shenlong, or Heavenly Dragon, reusable spaceplane. The mission was launched aboard a Long March 2F rocket from the Jiuquan Satellite Launch Center in northwestern China's Gobi Desert. The flight is understood to be the third for the experimental rocket plane. The first orbital test was a 2-day mission undertaken back in September 2020. That was followed by a second, much longer flight lasting 276 days, which was launched in August 2022. The Shenlong is thought to be a Chinese copy of America's X-37B unmanned space shuttle. The US Space Force uses the X-37B on classified long-duration orbital missions, the latest of which is just launched. Beijing's thought to be using the Shenlong on reconnaissance, satellite deployment and experimental technology testing. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. The World Health Organization has declared a new COVID-19 variant, JN.1, as a strain of interest. JN.1 has been spreading rapidly and has now become the dominant strain of COVID globally. The JN.1 strain was previously grouped under its parent Omicron variant, known as BA.2.86. The World Health Organization says that based on the available evidence, the additional global public health risk posed by JN.1 is low, although with the onset of winter in the Northern Hemisphere, it could increase the burden of respiratory infections in many countries. New research using data from 3 large studies has found that not all low-carb diets will help you keep the kilos off to the same degree. A report in the Journal of the American Medical Association found that low-carb diets that emphasized high-quality proteins, fats and carbohydrates from whole grains and other healthy plant-based foods helped slow down weight gain compared to low-carb diets that emphasized animal proteins and fats or refined carbohydrates. The authors say that all this suggests that nutrient quality has a crucial role to play in maintaining a healthy body weight. A new study has found that monarch butterflies use landmarks to remember the location of their favourite foods. The findings, reported in the Journal of the Proceedings of the Royal Society B, show that this level of spatial memory has been observed in bees and ants before, but this is the first time it's been shown in butterflies. The experiment involved several identical feeders being placed inside a flight cage, but with only one feeder actually providing food. Across multiple days, the butterflies learnt the location of the feeder with the food in it in relation to an artificial tree landmark, after which the researchers moved the tree in the cage from its usual position as well as the food-filled feeder. But the butterflies were able to quickly learn that the feeder was always placed just to the right of the tree, regardless of its position in the cage. One of the perennial issues that skeptics have to deal with, and 2023 was no exception to that, was the never-ending flood of UFO sightings. In fact, we've covered so many UFO sightings on the show that some of our listeners are starting to feel we're deliberately picking on those who research and investigate this particular genre of the paranormal. And so I thought I'd raise the issue with Tim Mendham from Australian Skeptics.
Right, okay. One of the things is that they've had a fair go for 70 years and they still haven't proved. They've had so much publicity, so much notoriety over 70 years. They've been predicting from the year dot that the big reveal will happen any day now, and they've been saying that for virtually every year since the original UFOs were sighted near Mount Rainier.
I want it to be real. I would love to see this technology, but I want to see it. Show me the evidence.
Yes. Now, all the evidence is hearsay. No one has, the few alien bodies have been shown to be sort of, dummies. The alien bodies, not believers. And we have been waiting for 70 years for the definitive proof, and every proponent of UFOs or UAPs will say it is just around the corner. Well, if you have it, reveal it, right? I dare you. I'm protecting my sources. Yeah, fair enough. If you're a journalist, you're protecting your sources. You reveal it. Show us where these are. The latest thing is, of course, this huge craft, which can't be moved, but they've done buildings over them. Someone says there's up to about 12 of these around the world. It started off being one, but quickly grew in number. And people keep wondering what the building is. UAPs. unidentified anomalous phenomena, which is a term that covers a multitude of things, including Bigfoot and everything like that. It's not just aliens, okay? So that's why I don't like that term. It's just too vague. Unidentified aerial phenomena is a bit more interesting, but people point out, but it could be in the water. So it gets messy, and then UFO, unidentified flying object, quote, flying saucer, close quote, is pretty well known that it's an alien craft.
Well, no one actually called them flying saucers at the start, did they?
Well, actually, not true. What's his name? Arnold? I think of the guy's first name.
Yeah, the pilot, yeah.
The pilot. He said at one stage, okay, these are looking like things you flip across the water, right? You skim across the water. But he did use the term sources later on, and not that much later on. I mean, sort of within a short period of time.
Okay.
So the story that he called them flying saucers straight away is wrong, is correct. The story that he never used that term is incorrect, because he did. It's another thing. You dig down into the minutiae of alien mythology and legend, etc., and you find that what's true becomes a hoax, and what's a hoax becomes true. Anyway, why do we pick on UFOs? High profile. We pick on a lot of things. I wouldn't say pick on. We discuss a lot of things, and UFOs are just one of them.
We are simply following the news of the day, and we are commenting on that. And part
That's
of
right.
that commentary involves showing the proof. It's fine to make a hypothesis about something, but we need to follow the scientific method for that.
Yes. And that applies to a lot of areas. And
not just UFOs. Sorry if we sound like we're picking on someone. We're not, but we are wanting to see evidence.
That's right.
Show me the memory material that came from Roswell, which was
show me the anti-gravity machine. Show me all sorts of things. Show me the pilot. There's supposed to be a lot of crashes around, not just Roswell. There's a lot of crashes around the world. There was one that the Vatican had a hold of and shipped it over to America, supposedly.
Oh, that's Raiders of the Lost Ark you're thinking of now. That's
The thing is, I'll give you an example. Martin Gardner, a famous skeptic, now gone, unfortunately, wrote a book in the 50s called Fads and Fallacies in the Name of Science. Right? He was actually enlisted a lot of these things, which are still around, unfortunately, a lot of different sort of pseudosciences and things. And as soon as he did, he got responses from people who are believers in a particular one of the things he picked on and said, everything else you're right? They're rubbish. My one is real. And he got messages about every different subject that he covered along those lines. We used to have the case the Catholic Church used to praise us for criticising astrology. And fair enough.
That's very dangerous ground to go on now, considering what the next step is.
Well, we used to try and get astrologers to meet up with Catholics and stand back. I can understand people feeling that we're picking on UFOs or UAPs, and I understand people who say we're picking on unknown animals or we're picking on astrologers or we're picking on this. We are pretty open about who we
very
discuss.
Ecumenical as to who we pick on.
We are very ecumenical, and we will sort of anything which we're looking for the evidence, and that's the prime thing, whatever the topic is. And UFOs have failed to show me, right? A lot of claims. Yeah, there's so many problems with the UFOs that just don't make sense, and that therefore the believers in them are coming up with very creative solutions like portals and multiple universes and crossing over from one to the other to explain how they got here.
There are just physics problems that are really hard to overcome.
Physics problems, so you make up paranormal solutions. If you know your Occam's razor, you're creating more problems for yourself.
The simple answer is usually the correct one.
Yes. The simple answer is normally the best one to look at to start with. And so if you suddenly have to create a whole new area of science to explain how UAPs move, then you are just setting things up harder.
With Roswell, the weather balloon was a fake story. The crashed bits and pieces weren't from a weather balloon, but they weren't from a flying saucer from another planet either. They were from a secret American project.
There's a lot of secret American projects which are blamed for things.
Let me qualify that. I'm not talking about Project Mogul here. I'm talking about a new type of jet fighter or something like that, or some captured Russian MiG fighter or whatever. But there's going to be an explanation which is fantastical, but not out of this world.
Yes. You realise, of course, that the Roswell crash didn't actually happen at Roswell?
Well, it happened at two places. The thing hit the ground at one place, but then kept flying for a while and then landed in a gully further down the flight path.
It's a long way away from Roswell, as far as I know. It wasn't walking distance.
No, well, Roswell was the nearest big town. That's where the Roswell Army Air Force Base was, because in those days, the U.S. Air Force was still a division of the U.S. Army.
Right.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.